Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Deb. Hi, Deb. Tell us a few words about yourself and about the tool you want to show us.
Sure. My name is Deb. It's longer than that as we established, but I go by Deb. I have a background in data since 2009. I have been a software engineer in the past, and I've done a bunch of different things. I've been switching jobs quite frequently. That's probably not the highlight, but I have worked in healthcare. I've worked in manufacturing, and I've worked with companies of size like maybe a few hundred people to 150, 200,000 people, and worked in trying to build insights and intelligent applications as first an engineer and then later on as a product manager. I currently work at InfinyOn, which is a small startup, 10 people. We are seed funded. I work as the vice president product. I report to the CEO. I sought this rollout for the project, which I'm going to share. And the project that I'm going to share or talk about is called Fluvio. It's an open source streaming project.
Okay. Tell us more about that.
Nice. So Fluvio, the way we are thinking about Fluvio, and maybe it would make sense for me to share my browser window to share some diagrams here, is a lean streaming system. And I'm very deliberately choosing to not use the word platform because there are tons of platforms. So the core of Fluvio is like a runtime. And our thought process very deliberately from the beginning is that, look, you want analytics and a lot of analytics that you serve up to the operational system. It actually is consumed at the operational system. It's not consumed as a dashboard. So as an example, if you were to order a food delivery using a food delivery app, the amount of time that it would take for your order to come is also something that you see in the app, right? So it's very local in that sense. And in order to do that, you need a few different things, right? Messaging, streaming, then you need to process, right? You need to do transformations, and you also need to materialize, right? And then you distribute. Now, that's just a slice of the use case. The other part of the use case is to do large-scale analytics and building machine learning models and things like that. We don't deal with the modeling part, but if you think about the serving part and the data gathering part of the model, right? You need to standardize, you need to clean data up. So we actually built a very lightweight, high performance distributed system, right? And you can see it's written in Rust and WebAssembly. It's been around for a little over 4 years. This is the 5th year now. And then it's because it's written in Rust, right? It's a double-edged sword, right? So the adoption is focused in the Rust community in the beginning. And now with WebAssembly component model, we are expanding the scope of it. And the demo that I will show you will allow other programming language users, especially Python and JavaScript, which is what runs most of the web and data pipelines, essentially to build flows, right? So that's what the project is about. Does that start to answer your question? All right, so where do we go next? Do you have any follow-up questions, or do you want to see it in
Yeah, I
action?
want to see it in action. It's interesting, but a bit abstract. So I want to
Yeah,
see.
absolutely.
Yeah.
Absolutely. So I'll just share this diagram and then go into the demo. Basically, the demo that I'll show you is of our latest release, and we have a couple more dev preview releases to go, just because we are at the bleeding edge of Wasm component model, and we are actually using their dev previews to build our dev previews type of thing. And we are stabilizing very quickly. But the core of it is data streaming or a message queue like Kafka, let's say, as a proxy. But this is entirely written from the ground up in Rust. States are essentially timestamps, offsets, watermarks, and key value states of actual payload. Primitives, operators in our paradigm are things that you do with the data, like filters, maps, array maps, assigning time, grouping, flushing, etc. The modules essentially is a way or a conduit to write business logic. And what I will show you is in Rust because we are predominantly a Rust shop, but we have prototypes and demos which essentially use Python as well as JavaScript. But the reason why I will show you Rust is because also, the data community is quite enthused and excited by Rust. And you will see we have made it quite accessible. It's not like you have to work with everything, right? And then
I
you
have
build the entire
never
data pipeline.
seen
Sorry, go
Rust
ahead.
code. I have never seen Rust code, so will be
You would
first.
just see like some functions in it that hopefully is simple enough, right? Yeah. So we are abstracting out a lot of complexity. Let me share my terminal window and then share with you a quick demo here. I am assuming all of your audience and yourself, all of us who have worked in data for a little bit, we are all familiar with the word count algorithm, which was popularized by MapReduce. So I just chose that to show you as a demo. Now, I'll have to do a couple of things to get it started. I will start a local cluster, which is a local streaming cluster. Entirely from a single binary. It's a single command to download. It's in the GitHub README. As soon as you say cluster start, it starts a single streaming processor, SPU. That's one partition and a streaming controller, think like the control plane. Now, you can obviously give more parameters in the command line to partition more or whatever, but we won't really need that for our use case in this case. Now, I'll show you what I have.
A Kafka stream, or what exactly happened? Like, what did you create?
This is a Fluvio stream. Like Fluvio is an entire.
Like conceptually, the thing you created, it's a stream
It's like
where.
a Kafka cluster.
Mhm.
Conceptually, it's like a Kafka cluster, right?
Mhm.
That is running locally on my system. But Fluvio, it's a Fluvio cluster because Fluvio is like 50 MB compared to Kafka 6 GB, right? It's
Mhm.
much leaner. So it's all of our own tooling, right? Now, I'll show you what I have in this directory so that we can get a picture of what we have. I have a YAML file, which is the data pipeline composition, which I'll show you. I have a local connector. If I want to run, I'm going to get data from HTTP source where we have some synthetic data generators. This is like a quotes connector I'll show you. And I have a YAML configuration, which is going to, what would you say? This configuration will actually use this package and reach to the point which is like streaming data. So I'll show you these steps real quick. But before I do that, I need to download one quick thing. And that quick thing is this. So let me actually go to the stream connector configuration. So if you look at it, it is actually hitting an endpoint which we host synthetic data over here. And you can see URL that endpoint, and I'll just do it here. What will happen is it will just stream data, which is JSON. And what it is streaming is it is streaming a quote and the author of the quote, if you will, or whoever said that quote, right? So this is like a streaming API synthetic data generator that we host on our own, basically, to show this demo. And this connector uses this JSON to JSON transformation called Jolt. This is a Rust implementation, which we use as a smart module that I showed you. You don't have to, the implementation is all abstracted out, but I just need to download it to use it, right? So I'm going to click out of it and download the Jolt connector. So you say Fluvio SM download. Actually, you can say Fluvio hub SM download, and that will download this I package. It's same idea like this, a tiny binary into the local cluster, which is running on this host and port. Now I can call this package to run a connector, which is basically running an HTTP connector to connect to that streaming data source. So I say CDK, CDK's connector development kit, deploy, start, and I basically call that I package and pass the configuration file that I just showed you, right? So once I do that, what will happen is it is now running a process, and all of this is self-hosted, which is the cool part. You can host it wherever you want, right? So now if you basically say Fluvio topic list in my local cluster, it created a topic called sentence. This is like Kafka topics, and it is, showing the default retention. And if you say Fluvio consume, I don't want to consume that one yet. I don't have it. Sentence. CNT. But to type properly. Oh, jeez. Why did it? Okay, there you go. So you can see now that it is, and the Jolt transformation, it just takes the quotes and not the author, right? So this is like a streaming topic, which is continuous streaming. Now let it stream. Let's switch to something else and talk about this composition, right? So the idea of this composition is this. There is a pipeline file, right, called data pipeline.yaml, right? And we are trying to build a stateful service where we are going to count words. We're going to count words and find the top words, and we're going to do it on tumbling windows of 20 seconds, okay? So if we look at the data pipeline file, we will find the composition, and this is what is in dev preview right now. So it starts with some metadata, right? Namespaces, org, this kind of thing. Configuration. So configuration, where you see converter, it's like essentially a SERDI, a serializer, deserializer. You can use avro, protobuf, whatever has your schema and your types. That's basically the idea. And you say in the consumer, what is your offset or starting endpoint, right? So you start at the beginning, 0. Then you go into your types, and now all of this is inlining right now because this is a straightforward, example, but you can basically reference different files, right? So you could have a file with your schema contract and your data types, but all of these things are pretty small, so it's all in the same file. And if you look at the types, these are the data types, right? So you get the string input, and the word count is a key value pair with a string and a number, and then top words is what it produces the output. It's a list that it will produce. Then you go into topics. We are taking input from the topic that you see flowing in on the left, right? And then we are going to produce an output topic, which is most frequent words. Now, how do we produce that output topic? Well, we produce that output topic by a very deterministic paradigm of creating services. So within services, there are operations, and within operations, there are functions, and that's what you will see. So the service is a word processing window, and it will take the input type of topic sentence, and it will transform in tumbling windows, as I mentioned, and every 20 seconds flush the data. In order to do that, it has to maintain a key value state, right? Because it's retaining count per words, and that's the property over here. And then you go into the operations. Now, this is the Rust function, the cool stuff, right? This is the function that is running. Now, obviously, everything else you will see, this is like Ruby on Rails type of approach, right? Where you just like write the function and the scaffolding generates, right? So you see operator flat map. We already have that. And what it does is it basically splits a sentence into strings. We all know how that works. This is just the Rust syntax. So it's going to take white space and it's going to split that. Then it assigns a timestamp because, as you see in the payload, there's no timestamp assigned. So you're going to assign a timestamp so that we can calculate windows. Then it's going to group by the words, which are the same words. So it's going to do, this is a function here. Now, all of these could be function files written in different places, and you can like compose and bring them together. So it's going to just like make it into lowercase and filter and then collect it. Now the operator will process, which is going to increment every word count, right? And then the aggregator will find the top 3, right? So the aggregator is probably the most complicated function here because they had to look at some conditions. Finally, there's a flush. This flush part is key because what happens in a window is like, okay, what if there is no new data? And you have past 20, so you need to flush that data, right? So that's basically the flush part of it. And then it writes it into a sync topic, which is most frequent words, right? So that's the idea. Now, here is the workflow of how we build it. So we say SSDK generate. And SSDK stands for Stateful Service Development Kit, okay? So once you generate, it generates a project. And basically that project is, as I mentioned, from that data pipeline file, create the entire microservices that you need to run that data pipeline. And because these are Rust functions, they've created Rust functions, you could have .py or .js, right? And so everything that we did with the topics, and by the way, this is the cool stuff. So all of these WIT files are language agnostic types based on the WASM component model, right? So inside those files are types which can map to any programming language, whatever. So we created 25 directories, 24 files, whatever, everything is good. We can do now SSDK build. Now this is where the rubber meets the road. Hopefully demo works properly. This takes a few seconds for everything to compile. Okay, so that sounds like it's all good. And then you say SSDK run. And then there's a UI flag. Now the UI is the cool stuff which we are almost ready with. I will show you a glimpse into the UI, and I'll share the window. Let me copy that URL and open it in the other screen and show you what that UI looks like real quick. So basic idea is that it's like a workbench. It's like a hub and a studio, right? Hub has got a sort of services, operators, functions, types, each of these things for VCBig drag and drop, right? And this is like a studio where you see, okay, fine, what are the services you're running? So if you look at that YAML file, that data pipeline, this is what is happening. It's a service. Inside that service, these are the operations. This is the input. That is the output, right? So far, so good. Do you have any questions?
I do, but maybe they're more
Maybe
like
okay. We are almost done. Almost there. That's okay. Good. So let's go to the terminal. So now it's basically running this service, right? And inside this service, you can say show state, for example, right? And you can see that it's got timestamp watermark. You can see count per word, which is the key value state where we're counting, and there are offsets. So now we can just, sentences here, I can just close out of it and say Fluvio topic list. Oops. Topic list, and it created a most frequent words, right? So Fluvio consume, and instead of sentence, we'll just do that. And I'll do -b from beginning. So basically now this is the materialization, right? So it's materializing the data in the topic, and every 20 seconds as the tumbling windows, right? It just keeps on updating. And that's your like simple data pipeline, which is operating on streaming data, giving you analytics, insights, whatever, right? And you can complicate this thing as much as you want to, but obviously we want a simple demo for people to comprehend. And yeah, that's basically it.
So as I understood, what we have just done is there is first the data source, this HTTP endpoint. So
Yeah.
what we did is we created a consumer from this HTTP point, which would immediately publish the transformed data to another stream, right? And then from this
Yes.
stream, there is another consumer that consumes from this stream, which is this pipeline. So it's not just one step, it's multiple steps. And these steps we defined with this pipeline YAML, right?
Yes.
And then you compiled this pipeline YAML, you started it, and then it started consuming from the sentences.
Exactly.
And then we publish it to another stream, and then in turn there could be another consumer that reads these top words and does something with them. Right?
Yes. 100%. And you can think of this as the operational application can consume in a dashboard or something where it just shows the update that it needs to show, the latest up-to-date data. But obviously you can write or pipe the data, which is raw or any state intermediate, to a data lake in any kind of Parquet flavor, or to a database. That just becomes a distribution integration wherever you want to, right?
Mm-hmm. And then the purpose of this pipeline file. So what we did there is we defined steps, and we defined some code there. And from that YAML file, what we got was a bunch of code, right, which got compiled and started consuming. And then wondering what would be the typical flow, like how would I use it? Would I, if I, let's say, need to change something, add another step, or maybe fix a bug, do I go to the YAML file and edit it and recompile, or do I go to the code, or what's the idea?
That is an awesome question. I love that. So the idea is that within the context of SSDK or Stateful Service Development Kit, it deals with the compositions. So you can, in essence, or I can, in essence, right now, have multiple versions of the YAML file, and within that CLI, I have updates, and I could run in parallel, right? Now, it depends on what you're changing, because even within the composition, you have got, topic schema, you've got operators, you've got functions, right? So we treat each and every aspect individually, right? So if you are changing the function, you can change the function file, which will be its own piece that you version control, and you can cross-reference it to an SSDK configuration, a data pipeline configuration. If you're changing the source topic schema, that part is obviously the integration, right? Where you say, okay, fine, you have the HTTP connector, which is getting the data. Now, if you notice, it's already smart enough where if, let's say, the schema of the source system changes, let's say I add a quote, I add an author, I add something when it was said some year or whatever. But in the topic for word count, I only want the quote. Then I don't need to change anything. But if I suddenly want to get something else, then that just means that you redo the connector, and it just like picks up, and the process just picks up from like, okay, these are the new types or new columns that you got, and it just like writes another version of the topic. So the paradigm is so flexible that you can do whatever you want with it.
But I guess like if we change code, then like it would be difficult to go back from the code to the YAML file.
Depends on what code you change you're talking about. Which code are
The
you
generated
changing?
one, right?
The function or the source?
Functions, yeah.
Yeah, no, the functions, basically we reference the functions right now, what I inlined, right? Those functions, you can think of them as like just files without any kind of, what would you say, imports or whatever, right? You just like write the business logic. So if you have multiple versions of the business logic, you just reference that file and you give it the basic metadata, and it can just pick
Okay,
it
I
up.
can, instead of just putting the code there, I can say, hey, look, the actual code for this step is here in that
Yeah,
file.
exactly. Yeah, you
Okay.
can create separate files and directory structures and everything.
Okay, makes sense.
Yeah.
See.
Yeah. So
Yeah,
our
that's
goal with this is like, okay, so let's say this is kind of my pain. I never worked for a company which creates data tooling. I've always worked for healthcare manufacturing where data tools have pitched to me. Okay. So the problem is the data scientist speaks different language, Python, SageMaker, TensorFlow. The data engineer speaks different language, which is Spark, Big Data, Elastic, MapReduce. The front-end applications speak different language, DynamoDB and their JavaScript code, right? Well, how do they interoperate if you don't give them a layer, a dictionary to interoperate? The data pipeline file and the functions are just that. So in essence, you can have different teams writing different functions in different languages. As long as you are giving those metadata information, you can pull them together and create a pipeline where they can now find themselves walking to the middle of the bridge together to meet each other, even though they don't speak. They're not like hollering from the two ends of the bridge to say, hey, I need this something, you give me something, because you have to give them some place to interoperate, right? And that's what we are building.
Yeah, that's impressive. Thanks. How many people are working on that?
So we are, like I mentioned, a 10 people company. I am one of the 10, and we have had periodically like a couple of
Is
extra
the
people
VP of
here and there
product,
consulting.
you also code, right?
I write code, some code, yeah, not production ready. Like I write the Copilot code, right? And then the engineering team would, but I have been an engineer, so it's not horrible, right? And then we have like some say 30 to 50 contributors at any given point of time. That's expanding as we enable people beyond the Rust community. We are seeing a little bit more traction now, right? And people are asking for different integrations, different connectors, and those stuff we can do because we already spend the time building the dev kits and so on.
So if somebody wants to become one of these 30 external contributors, how do they go about that?
Well, they just come to Fluvio. We have our Discord as I mean, as if we needed yet another Slack or Discord, but I mean, we use Discord. We also monitor our emails and things like that as well as we could. But basic idea is there are some issues that are marked as good first issues, and I'm starting to log in some bounties in Algora as well for people who are interested in doing some binding generations, for example, like the Python client that talks to Rust. It uses PyO3 to generate bindings, and we have like small tickets that can help people familiarize with the access layer of the system. And then if you are interested in the core distributed system, there are some harder issues which you can come and talk to us. And all of our people, the developers who come, they are quite happy with our response time, because even though we are 10 people, we are all very deliberate about like trying to solve this problem. So we typically respond within a day or two, and people are quite happy with that.
And the link to the Discord server is in your GitHub repo, I assume.
Yes, it is. It is in the GitHub repo. Yes.
In the README. Okay.
Yeah.
So what are your plans? So you mentioned briefly that now you want to focus more on different other languages, not just Rust, expanding the Python and JavaScript community.
Yeah.
Is there anything else or anything more specific?
Yeah. Well, the thing is, like, we are a for-profit company. We raised some venture capital before I joined the company. We have like, I think $6.5, $7 million. We have a runway of another, let's say year and a half or so. And we are seeing a lot of people who are, let's say, in the space where they either need to integrate a ton of different APIs to enrich and create data sets in e-commerce, fintech, and this type of thing, or some companies which are like selling e-bikes or putting stuff on ships, like IoT basically, and they want us to build some non-functional, whatever would be enterprise ready features, right, for them to deploy and put it in production. I showed you everything local, but we have a cloud version which is hosted using Kubernetes, and it's obviously cloud agnostic. We host it in AWS, but it could be any cloud. So we are basically 50-50, right? First order of business is to deploy stateful service development kit and get traction around that. And then the second order of business is to meet these companies where they're at and essentially help them. Because if you think about Kafka or Red Panda or whatever people have been using, one of the first questions you get is like, okay, how do I migrate? I mean, I am convinced. How do I migrate? And when do I see value? Now, I can't tell you like you have to develop 3 months worth of thing, to get value. I mean, I started in the heydays of big data. We have been promising this same exact thing that I'm trying to show you for the last 15 years. Like no one believes you when you have to show and not tell, right? So I'm trying to build the features that would help people migrate, and the observability, visibility, like the stuff that is executing in WebAssembly now. There are metrics also. So the observability is built in so that you can detect where the pipeline failed. There's stuff like dead letter when your schema changes and you don't know in a third-party system, so that you can get alerted and you take action. So one of the things I'll tell you is like when I was talking to the CEO to interview for this job, which I was like, I want this job. I don't know if you have this job or not. He said something very, very intuitive to me. He said that, look, all data observability and lineage is essentially your source data and what you're doing on that data. You need to do after the fact if you don't know what you're doing with your data. And that's not helpful, right? If you come from, and everyone's talking about make it to the left, make it to the source and whatever, we are also trying to enable that, because you need to have some degree of determinism of your source systems and your data quality before you can go troubleshoot from the analytical system. If you came from the other side, it's just going to compound your costs, which already we are seeing in this market is very difficult, right? So we are just like being very deliberate. And the other final thing is that all the people that works in this, except me, their background is infrastructure management. Like they are hardcore software infrastructure guys. They sold their last company to Nginx and we're managing service mesh. So we are not taking the approach that someone who came from Splunk would take. Our approach is different because we don't want to do CDC. We know CDC is expensive over time, right? So we want to do the right thing that makes sense from a computer science fundamentals perspective and enable businesses that want to get on it. The cost of that is, well, it's a small, less mature platform, and you have to there is some rust that you need to look at or whatever for trouble. But we are trying to make that easier, as easy as we can make it.
Mm-hmm. So if you ask a VP of product about plans, you get a very detailed answer, right?
Of course, yeah, absolutely, absolutely, yeah. I want to give you the context as well, right? So,
yeah, like last one. Do you have any advice to anyone who is watching this?
Advice. Yeah, absolutely. Absolutely. I have been a data engineer, man, and I'll tell you that when my title changed from expert data consultant to senior software engineer, I was really bummed because I thought there was a level gap. Here's one thing I'll say. There's a lot of noise of people saying that data engineering is not software engineering. Everything is writing software on top of a hardware. It doesn't matter what you do. If you don't know that, at the layer of abstraction will determine the ability that you will have. So if you play at the layer of abstraction that's at the top of the pyramid and the foundation is broken, that limits your ability and therefore your value. And all the people that get laid off are at the surface level. If you want to build some core competency, go down deep. That's what my advice is.
Yeah, which means also learn the thing
Infrastructure. Also learn the infrastructure. Also learn. And people I want that's a low code, no code. No. You need to understand the data structures, understand the models, understand the infrastructure, understand. I know they're boring, but Rust on their website, they say that this is a boring language and that's their testimonial, right? That's why it works. If it works on my system, it will work on yours. You can just download it and do it. It doesn't happen for most other cases, right? So the hard thing about hard things is like, okay, if you want an easy way out, everyone can do it, and you're going to be out competed, right? If you want to do some hard things, then that's where you develop true competence, true muscle, right? It's not easy. Like to go and grind it out a little bit.
Okay. After this talk, I should probably go and revise all these data structures. Okay. Yeah. Thanks for the demo. Thanks for answering my questions. Thanks for the device. And yeah, please, everyone, give them a star. Maybe you can show us one more time, like how exactly we can go and give you a star.
Oh, the repository?
Yeah.
Sure. You can just go GitHub, just search Fluvio GitHub, Fluvio Latin for river. That's our streams, right?
0.4K stars, that's not enough. So we need to give more stars. That's not enough stars. We need to give more.
Oh, yeah.
Please, everyone, do that.
Yeah. Come and make it like 50,000 or something. God only knows like how all those stars come from. But I mean that's good. I just look for contributors. If you want to like play around with it, I'm more than happy to support you. That's like my biggest thing. But star is a cheap thing that anyone can
but
give.
like contributors matter more, right?
Yeah, absolutely.
Okay.
Would love to support you.
There's somewhere there is also a link to the Discord channel.
Yeah.
So check it out, and yeah, I guess that's all for today. So
yeah, and I'll give you all the links to put on the video, right? Like you'll have them so that people don't click somewhere else. They can just like do it from there.
Okay. Yeah, thank you.
All right. Thank you, Alex. It was great.